Area involving circles. To find the area of a shaded figure with a region cut out from the greater whole, first identify the basic shape of the overall shaded area, as if the other section was not removed. Then identify the basic shape of the non-shaded region in the figure. Calculate the area of both regions, then subtract the area of the non-shaded region from the area of the greater shape. Looking at this first example, to find the area of this shaded region, identify that there is a circle inscribed in a square defining the shaded region. Find the area of the square with side lengths of 4 yards by multiplying length by width, or since the sides are of equal measure, side squared. Substitute and calculate. The area of the greater figure is 16 square yards. Next, find the area of the non-shaded shape in the square. To find the area of the circle, use the formula area equals pi times radius squared. Since the diameter is the same length as the sides, which is 4 yards, the radius is half the diameter, so the radius is 2 yards. Substitute 2 for the radius and 3.14 for pi, and calculate the area. 3.14 times 2 squared. Follow the order of operations, and the area of the non-shaded region is 12 and 56/100 square yards. Finally, subtract the area of the non-shaded circle, 12 and 56/100 square yards, from the area of the square, 16 square yards, to get the area of the shaded figure, which is 3 and 42/100 square yards. Looking at this next example, to find the area of the shaded region, first find the area of the semicircle and then find the area of the triangle to subtract the non-shaded area from the greater shape that is inscribed inside. To find the area of the semicircle, use the formula area equals pi times radius squared divided by 2, since it is half of the circle. Looking carefully, the height of the triangle is the same as the radius of the circle. So the radius is 4 yards. Substitute 4 for the radius and 3.14 for pi to get area equals 3.14 times 4 squared divided by 2. Follow the order of operations to get an area of 25 and 12/100 square yards. Next, find the area of the triangle using the formula 1/2 base times height. The radius of the circle is the height of the triangle, and the diameter of the circle is the base of the triangle. So the height of the triangle is 4, and the base of the triangle is 8. Substitute the values to get 1/2 8 times 4. Multiply to find the area, which is 16 square yards. Finally, subtract the area of the triangle, which is 16 square yards, from the area of the semicircle, which is 25 and 12/100 square yards, to find the area of the shaded region, which is 9 and 12/100 square yards. Looking at this next example, to find the area of the shaded region given, find the difference in the areas of the two figures by subtracting the area of the semicircle from the area of the rectangle. The width of the rectangle is 18 centimeters, which is also the diameter of the semicircle. The radius of the semicircle is the length of the rectangle. Since the radius is half the diameter, the length of the rectangle is 9 centimeters. Substitute 18 for the length and 9 for the width, and multiply the length by the width. So 9 times 18 is 162 square centimeters. Next, find the area of the semicircle by dividing the area of the circle by 2. Since the radius is half the diameter, substitute 9 for the radius and 3.14 for pi to get 3.14 times 9 squared divided by 2. Follow the order of operations to calculate an area of 127 and 17/100 square centimeters for the semicircle. Finally, subtract the area of the semicircle, 127 and 17 hundredths square centimeters, from the area of the rectangle, 162 square centimeters, to get the area of the shaded region, which is 34 and 83 hundredths square centimeters. To find the area of the rectangular paperboard, first find the area of the rectangle and then find the area of the semicircle cut out to find the difference in their areas. The length of the rectangle is 34 inches. The width is 20 inches, which is also the diameter of the circle. To find the area of the rectangle, multiply the length and the width, 34 times 20, for a value of 680 square inches. Next, find the area of the semicircle. The radius is 10 inches since the diameter of the circle is 20 inches, because the width of the rectangle and the diameter of the semicircle are the same. Substitute 10 for the radius and 3.14 for pi, 3.14 times 10 squared divided by 2. Follow the order of operations and the area calculates to 157 square inches. Finally, subtract the area of the semicircle, 157 square inches, from the area of the rectangle, 680 square inches, to find the area of the paperboard, 523 square inches. Look carefully at the next problem and its figure. Notice the perimeter of the training field is made up of the widths of a rectangle and a circumference of a circle. That rectangle is just positioned in the middle of the circle. The width of that rectangle is 93 meters on both sides. So those widths combined equal 186 meters. Next, add the value of the circumference of the circle to find the total perimeter. The length of the rectangle is also the diameter of the circle, which is 70 meters. The circumference of the circle is pi times the diameter. Substitute 70 for the diameter and 3.14 for pi and multiply. The circumference of the circle is 219 and 8/10 meters. Finally, add the width of the rectangle and the circumference of the circle, 186 meters plus 219 and 8/10 meters, to get a total perimeter of 405 and 8/10 meters. To find the area of the whole training field, find the area of the rectangle and the area of the circle to add their values together for the total area. The length of the rectangle is 93 meters and the width is 70 meters, which is also the diameter of the complete circle. Multiply the length by the width to find the area of the rectangle. Substitute the values, 93 times 70, and multiply for an area of 6,510 square meters. Next, find the area of the circle that is split to make the field. Since the area of the circle is pi times the radius squared, find the radius. The radius is 35 meters since the diameter of the circle is 70 meters. Substitute 35 for the radius and 3.14 for pi, 3.14 times 35 squared. Follow the order of operations, and the area of the circle is 3,846 and 5/10 square meters. Finally, add the area of the circle, 3,846 and 5/10 square meters, and the area of the rectangle, 6,510 square meters, to find the area of the training field, which is 10,356 and 5/10 square meters.